Hi everyone, let's start this 3.6, actually working through some examples. These first few I'm going to do are going to be reminding us that we can't, some of these come just from a simple transformation, although they may not look like it to begin with. So the first one I'm going to do is this function, and look at it as 2 over x minus 3. So we can see those asymptotes showing up and so forth. So first of all, it doesn't look like this one might be a transformation of one that I know. It is actually a transformation of our 1 over x. I want to remind us what 1 over x looks like. We looked at it in the book when we did the skim through, and this is the function that has these wonderful, curves. It has that asymptote of both of the axes. So we have a vertical asymptote on that y-axis, that y, or x equaling 0, vertical asymptote. It also has that y equals 0 horizontal asymptote as we go through this. Now to see that this is a transformation, I'm going to make it a little bit more apparent. So instead of this x, we have that x minus 3 in there. So that minus 3 that's sitting there is inside that function. So we can see that being inside the function. I'm going to make this a little bit more apparent. I'm going to pull that 2 out front, thinking of it, written it this way. Notice they are the same because I could write this as 2 over 1 and then multiply my numerators, multiply my denominators. So this 2 is kind of on the outside. So I could write this as 2, this is g, of g, so it's being 2 times g of an x minus 3. So you can see the minus 3 on the inside and the 2 on the outside. So the minus 3 on the inside is going to move this curve to the, and again, dramatic pause for you guys to answer. It's going to move it 3 units to the right. And this 2 is going to be multiplying those y values, so it's going to be a vertical stretch. So it's going to go 3 units right, and it's going to be a stretch 2 times. All right, so we're going to actually do that here. And to help me a little bit, I might put some points on here. So 1, 1 is a point, and this would be 2, 1/2, just so we can see that stretch going in there. This would be the point, -1, -1, and then we'd have that point, -2, a -1/2. So we can see the stretching happen. All right, first of all, we're going to move it 3 units to the right. So this vertical asymptote is also going to move 3 units to the right. Whoops, I missed. Okay, and you'll notice that this also, if we looked at the denominator, and we set that denominator equal to 0, x equaling 3 would be a 0, and that would be our vertical asymptote. So we're going to be moving this also 3, but then we're going to stretch it. So we're going to be taking those y values, so this 1, 1, multiplying that y value by 2, so we're moving it and stretching it. So our point here at 1/2 is also going to be multiplied by 2. And it will still look similar to that. These guys again are being moved and stretched. So I'm going to stretch that to a -2 and stretch my 1/2 to 1 and kind of throw this in here. Okay. We could find our y-intercept as well, just to make sure it makes sense as to where I drew it. Y-intercept is when x is equal to 0. So putting 0 in for x, my y-intercept is at a -2/3, 2 over that -3. So -2/3. So my dot was a little bit high, but that's okay. All right, so again, remember that we can a lot of times see these as transformations of this 1 over x curve. Okay, another one that I'm going to do looks like this. So 3x plus 5 all over x plus 2. And I am going to tell you that it is a transformation of my 1 over x. And now you're looking at that and you might be thinking, no way. And I would agree with you. At first glance, I would not have noticed that it is a transformation. The only reason I know it's a transformation is because someone told me. And so I'm going to try to force it to be a transformation of that curve. I will start the next video with this specific example as well and treat it as if it isn't a transformation, and you'll notice we're going to get the same curve. And to be honest, I would not spend a lot of time trying to find transformations, because a lot of times it's harder to do that than to just jump in and go through the process of graphing it the way we'll be graphing them, as you'll see in the next videos. But I want to show you in this video that sometimes transformations are hidden, like in this one. And in order to find our transformation, what I'm going to do is I'm going to do some long division. So we're going to take this 3x plus 5, and I'm going to actually divide it by my x plus 2. And so I'm going to take my x into 3x, and I need the 3. And then I'm going to multiply this whole thing by 3. And we've done long division before. Now we subtract. So I get that -1 remainder. So we would write this as 3, and I'm going to write this as plus a -1 over x plus 2. And to make it even more apparent, I'm going to flip the two terms around. So I'm going to write the fraction piece first, and then I'm going to add that 3 onto it. So this was our g, was 1 over x. Very similar, this piece is like a negative g of x plus 2. So we saw that in the first one. And then we added 3 to it. So that means we're going to be taking our curve, this inside our function, so we're going to move 2 units left. Okay, so we're going to take this guy, move it 2 units to the left, so we'll see that vertical asymptote moving. We'll also notice it's a 0, but I'll hit that again in the next video. Then this negative is multiplying all those negatives, the y values, so we're going to be -1 times our y values, which is going to cause it to flip vertically. So it's going to make it, the x and the y's, or the values are going to flip upside down. Hopefully you guys can see me do this. I don't know. I'm kind of flipping it upside down here. Okay. And then this plus 3 is going to move the whole thing up 3 units. So let's go and actually do that. And I think I'll try to squeeze it in here. I think I can do so. Okay, and we didn't do a whole lot of stretching, but just flipping it upside down. So first thing we did is we moved it 2 units to the left. So that vertical is moving 2 units to the left. So I'm going to put that dotted line in there. Okay, so this guy is going to flip upside down. So we're going to have a piece down and then the other one will be up. But we're also moving it up 3 units. So that horizontal asymptote also moves up 3. So I'm going to need a dotted line up there. So here's my x equaling -2 and my y equaling 3. And you will see those asymptotes show up again in the next video, and we just jump right in. Okay, but I wanted to show you that yes, sometimes these pieces are a little hidden. Okay, so moving this over, that 1 would have gone down to a -1, but then we moved it up 3, so 1, 2, 3. This should be here at that half mark, and we're gonna, this should kind of look That's drawn really poorly. Here we'll be up at this guy up here, and that half, and kind of flipping it this way. So very rough, and I'm sorry that I squeezed it in there, but try to save paper, be, you know, green and everything like that. I do use scratch paper, so paper that's been used over, so I kind of am saving the environment as well. So here we are, we moved it over, we flipped it, and we moved it up. So hopefully that can show you that these transformations sometimes don't look like transformations. So here's kind of going backwards. But again, I would not have seen this transformation unless someone had actually told me it was a transformation. I would be doing this problem like I will in the next video, basically diving in and jumping right into it, going through the processes that are discussed in this section. Transformations I might see in this one. Maybe I would see it, but again, I would still redo those using the methods that we'll learn later too. So I kind of jump in. So hopefully this will help. And again, I do more examples in more videos, so there are more videos to come.